the Westby Field Private Airport.
I'm Nikki.
I'm Amber.
And I'm Anaïs.
We chose this location to do our math trail project because there are so many different geometric shapes that come in and out of the airport.
There are long runways composed of rectangles, cylinder-shaped gas tanks, and trapezoid-shaped go-karts.
We'll show you around.
So here in the cockpit we have lots of screens. They're going to be in the shape of rectangles. The area of a rectangle is area equals base times height. Here we have the base of 15 centimeters and we have the height of 10 centimeters. If we were to break them up into little squares to say that there are 15 squares going this way and 10 squares going this way, you would multiply the two numbers together in order to get the total number of squares that take up the whole screen. So for example, 15 times 10 is going to be 150 centimeters, but don't forget that you have to do centimeters squared because you are multiplying the centimeters by the centimeters to get centimeters squared. So your total is 150 centimeters squared.
We see how this wing is perpendicular to the base of this wing. Together, they form a 90-degree angle. If it's perpendicular and they form a 90-degree angle, we call this a right angle. However, if we take a look at this one, at this flap right here, if it would have been like this, it would have been a 90-degree. However, since it's leaning a little bit in, it creates a much smaller angle. That angle is less than 90 degrees, meaning that it's an acute angle.
So this is our orange fan here at the airport. There are 6 triangles when you look at this fan. It's basically describing the area of a circle, which is pi r squared. As you can see, the triangles are formed here in the circle. There's 1, 2, 3, 4, 5, 6 of them. This is because when we inscribe any n-gon in the circle, then cut out the triangles and align them, they form a parallelogram. We basically know that the bases of the parallelogram equals to the circumference of the circle, which is 2 pi r. As the triangles in that parallelogram get smaller, so basically if you cut out these triangles that are in a parallelogram and they get smaller, you're going to form a rectangle. When you form the rectangle, it's because the height of the triangles are getting longer and equal to the radius of the circle. The area of the rectangle equals the area of a circle, and this is how we basically come up with this shape.
This is a GPU, which is a power generator for all of the airplanes. This is a hexahedron, because hedra means all of the faces. And there are 6 faces total, hence the hex, because hexahedron means 6 faces total. It can also be called a rectangular prism, because the base is a rectangle. These two terms describe the same thing, as you can see. A vertice is how many times that they meet. And in this rectangular prism, they meet together 8 times. So there are 8 vertices. You might think that it's a cube at first glance, but that is false, because not all of the sides are the same length.
We can observe that the whole building is of a rectangular shape, and if we were to fold it horizontally, that would be one of the reflectional symmetries, and then we can have another reflectional symmetry folding it vertically. However, if we fold it from corner to corner, that can be a reflectional symmetry because the shape would overlap. Then we can go on to talk about the rotational symmetry, and if we rotate it 90 degrees, that wouldn't count as a rotational symmetry because it wouldn't fill in the area of the original shape. We would have to rotate it 180 degrees in order to have it meet the rotational symmetry. And that's it for the symmetries.
So today we brought you into the cockpit of an airplane to show you the area of a square.
We showed you the orange fan where we described the area of a circle.
We walked to the front of the building to show the reflection and rotational symmetry.
We talked about obtuse and acute angles about the wings of the airplane, and we learned about the rectangular polyhedron of the GPU.
Thanks for flying with us!